Hello and welcome back to another video. In this one we'll be discussing the second order differential equations. Now, the second order differential equations split into two categories. We have a second order DE, or differential equation, that is homogeneous, and we have the second order differential equation that is non-homogeneous. Now, the second order differential equations that is homogeneous would be a y double dash plus b y dash plus cy is equal to 0. A homogeneous second order differential equations are equations that equal 0, and the second order non-homogeneous equations are exactly the same. So we have a y double dash plus by dash plus cy, and that would equal a function of x. That could be a number or a function of x. Now, in this video, we'll only be taking the second order homogeneous equation and its cases and how to solve it. Now, for this video, we'll be only taking the first case for the homogeneous equations. Now, and how do we solve this equation? For example, a typical solution would be y is equal to exponential r to the x. So exponential rx, if we take the derivative of exponential rx, we have y dash is equal to r exponential rx, and if we take the second derivative of that, we get r squared exponential rx. Now, if we take all of these terms and we substitute them in our equation here, so we have a multiplied by r squared exponential rx plus b multiplied by r to the rx plus c to the e to the rx is equal to 0. Now, if we take e to the rx out of the as a common multiple, we get e r squared. So if we do that, the rx plus b multiplied by r plus c, and is equal to 0. Mind the fact that e to the rx does not equal 0. Now we are left with a second order equation. So let's scroll down. We are left with a second order equation. We have ar squared plus br plus c. Now we must take the roots of that. We must find the roots. So one way is to use the quadratic formula, which states 1 r1 2, because we have the variable r. So root 1 and 2 is equal to minus b, positive and negative, the square root of b squared minus 4ac divided by 2a. Now, if we take this term here, because this term in the quadratic formula decides if the roots are real or imaginary. So in our case, so case 1, if the square root, or let's just take the term b squared minus 4ac, if that term is bigger than 0, then our general solution will be y is equal to c1 exponential r1x plus c2 exponential r2x. That would be our general solution. And now we'll take an example to show all we've taken now. Now we have this example. We have y double dash plus 5y dash plus 6y is equal to 0. Now our first step is to rewrite that second order differential equation into a second order function. So we have y dash gets replaced with r squared plus 5, and the y dash gets replaced with r plus 6, and that's our second order equation, and obviously that is equal to 0. Now we must find the roots for this equation. However, instead of using the quadratic formula, as it takes time, we will use the brackets method. So we have two brackets because we have two roots. R squared, we get it by multiplying r by r. Now we have a positive here. A positive multiplied by a positive is a positive, and a positive multiplied by a positive is a positive. Now, how do we get 6? We get it by multiplying 2 and 3. We must find a number combination that 1 multiplied gives us 6 and 1 added together gives us 5. So we have 2 and 3. So we have a 2 here and a 3 there. And now we have our two roots. So we have r1 is equal to -2 and r2 is equal to -3. Therefore, our general solution will be c1, the exponential of r1x, plus c2 exponential of r2x. Now we have c1, the exponential of -2x, plus c2, the exponential of -3x, and that's the final answer. And that's all for this video. Thank you for watching. Like if you enjoyed, don't forget to subscribe and share if it's helpful. Thank you.